red light on.
There is a red light on.
But I see.
Let me do a couple of jumping jacks.
You're good.
Welcome, y'all. Thank you for coming. Even though it's only 2, we still appreciate y'all taking time on your busy schedule. And what we're going to do is basically like we did last time, run through a lesson really quickly, but it would be a longer version in the classroom. That's kind of what your children's in the classroom. And this was created by our math coach. So a lot of the things are explanations and things she created this for us. And what our math coach does is tells us kind of what to teach, when to teach it, and so on.
Hold on.
What order?
Yeah, it keeps us in a certain order.
Okay. I just moved.
Oh, thank you. All right, this is the standard that we have started talking about this week. And it says fluently, they want the students to be able to fluently multiply multi-digit whole numbers using the standard algorithm. And we'll go back to standard algorithm in just a second. Last year, your child was supposed to get multiply a whole number of up to 4 digits by a 1-digit whole number and multiply 2 2-digit numbers using strategies based on place value and properties of operations. Illustrate and explain the calculation by using equation, rectangular arrays, and or area models. And the reason I said they were supposed to get it is because Common Core didn't come into effect till this year. So if you see your child doing a lot of different things for multiplication and you're thinking, why can't it just multiply? We're trying to catch them up from what they would have got if Common Core would have been last year. What they actually got was, this is the old South Carolina standards, apply an algorithm to multiply whole numbers fluently, and in 3rd grade, generate strategies to multiply whole numbers by using 1 single-digit factor and 1 multi-digit factor. All right, again, I just said the standard for 5th grade is fluently multiply multi-digit whole numbers using the standard algorithm. And what standard algorithm means, we all thought it was just the way we used to multiply, but it means a consistent and efficient way to multiply numbers. So this week, today specifically, we're teaching them how to build off prior learning to get to the present learning. I told mine this morning to kind of think about a flashback. We're flashing back to multiplication so you can see why we multiply. And what's in blue is what we're adding on this year. So they should have gotten 1s times 1s equals 1s, 1s times 10s equals 10s, and so on. Basically, if you look at it, they learned in 3rd grade, anything times 1 is itself. So this just replicated itself right there. And this year, we're going to do 10 times hundreds equal thousands, 10 times thousands equal 10,000s. Also, our coach wants us to throw in scaling, so we'll be mentioning that. Multiplication and scaling, if I multiply by whole numbers, my product will become larger. So if, your paycheck was 100 times my paycheck, we're scaling, making it larger. Procedures, what do my students need to know and learn how to do? Up to this point, they should have knowledge of basic facts. That's essential. That's what they got in 3rd grade, when you had to know your zeros and your 1s and your 2s timetables. Compose and decompose facts. We'll look at decomposing numbers today. Utilizing strategies, and 2 of those strategies, area model with base 10 blocks, and we're going to show you that tonight, and then open area model with decomposing, you'll see that tonight. Use algorithms, and 2 of the most popular, U.S. traditional, we'll show them that. That's what we learned in school, where you multiply your 1s, carry it, and partial products. You'll see a lot of that. I think they got that in 4th grade last year, because several of them today said, we did this last year. Also, we want to know those properties of multiplication, commutative and distributive. They got that this week as well, along with associative. I'm not sure why it's not included. All right, Ms. Harris.
Okay. All right, now that we have a better understanding of what the standards say, here are some strategies and algorithms we'll use to teach your children. Most days we do number talks, and it's a daily routine and that we use to encourage the development of number sense in the classrooms. And that means if you're number wise, you can figure things out in your head. And you can use your brains. I say bring your brains up, and here we go. So. And this is what your child sees when we do number talks. I have a square, and what I tell them, and we all do, if you're thinking, they come to the floor and they use their hands, and if they're thinking, they just got their hand down like this against their chest. When they find a strategy, they put up one thumb. If they can think of 2 strategies to solve a problem, they can put up another finger separately. So this means I am ready with a solution. When that thumb goes up, and I can tell when everybody's done it, and so we're ready to talk about the different strategies. All right, and they'll probably start with a simpler one, like 6 times 20. And there's several ways to solve this. I can say 20 plus 20 plus 20 6 times, right? Or another way would be, and we usually record it, we'll just say, I know what, let me see, 6 times 2 equals, that equals 12. And how many zeros do I have? And so that's another strategy. And I'll just usually write down what everybody tells me. Then we go on to the next one. Gets a little bit more complicated. 6 times 100. Well, they could add 100 6 times. Or they could say 6 times 10 is 60 and add a 0. So we just keep going and keep writing their answers, and they can re-voice what somebody else said and say it a different way and so forth. Okay, we get to the next one, maybe a little more complicated, but if they know their 12 multiplication facts, they've got that. Or they could go back to the 10 times the 2 and say, oh gosh, that was 120 and this is 600, I can add that up and I can get that. Stemming off what we already talked about. And finally, there's usually going to be a little eyeballing. This is one less than the 120, and some of them will say, okay, that's one less, so we multiplied by 6, so let's just get the answer for this and take 6 away. That'll give you the answer for that too. Or, even carry it further. They knew what 110 times 6 was, and then what 9 times 6 would add it up. There are a lot of just different ways they can do it in their heads. All right, and you heard Ms. Miller use the word decompose, and that's what we do with the distributed property. And Sarah, I can tell you we've done this week. 6 times 126 could be, we could break this up or decompose it into 100 plus 20 plus 6. Then we would go back and say 6 times 100 plus 6 times 20 plus 6 times 6. Then we get 600, 120, 36 for our answer of 756, which makes it easier to do than just saying, okay, 126 times 6 right up.
Right.
Watch out for this ruler, baby. All right.
Today,
Right.
did your children get this today?
Mm-hmm.
Okay. Yours, the parents get this today?
We did.
Okay. Today, your child received a sheet that shows them the different ways that we are going to be learning how to multiply numbers. And the ones that we dealt with today in class was the area model and also the open area models. The first 2, we'll get to the other 3 later. And the area model deals with concrete. That's where they build the actual model. And the open area model is where they draw a chart to represent what they built in the area model. And y'all are actually going to build an area model tonight. If you would get your board and a dry erase marker. And what I need for you to do is to draw a line. I have to tell my children it's beautiful and it's straight, so look with your perfect eyes and see that perfect line. And then you're going to draw another line down, and you're going to put a multiplication sign there. So your dry erase board will look like my bigger representation of it. Okay? And today, we also talked about the fact that These are our factors, 12 times 17. Our factors go on our factor line. We have factor, and we have factor. And what we have here in the middle will be our product, which is our answer. When we multiply factors on factor, we'll get product, which is our answer. All right, Ms. Miller talked about decomposing, Ms. Harris talked about decomposing. This is where they actually decompose their numbers. And so we are going to decompose one factor, which is 12, and we can decompose that to what can we decompose that to? 10 plus 10 plus what will give me 12?
2.
10 plus 2 will give me 12. All right, you should have some manipulatives on your table. I'll get this one out to you. And you will have a 100 block. You will have some 10 strips, and you will have some 1 cubes. And what we need to do is find which one of those would represent 110. So out of your 3, you have a green strip, an orange cube, and a yellow square. Which one would represent a 10? The green. So you will take these and you will bring it up to the factor line. Now you don't want to put it down into the product area because that is a factor, it's not a product. You use your factors to create your product. It's not a part of your product. All right, this is 2 ones, so how will we represent 2 ones? Where 2 of the little cubes. Yours are orange and mine are green. Now when we do this, we are making an area model. Area is length times width with no gaps and no overlaps. So you can't have them spread out all over the place. We are making a tight rectangle. Okay, now we're going to decompose 17, and we would decompose 17 into, no, can't decompose 17 into 100. What 2 numbers can I add together to get 17? Using place value. Harris?
10 plus 7.
10 plus 7, all right. All right. So now we're going to take our 10 stick and we're going to put it on the factor side. And how will we represent the 7 ones?
7 little oranges.
7 little oranges. Make sure you put it up tight. Because we don't want any gaps and we don't want any overlaps. And make sure also that it's not inside the product area. It's on the outside of that line. Okay? Now, we multiply that and we say 110 times 110, or in other words, 10 times 10 would give me 100. Now, some of my children today, they went and they put up 1010, which is fine. That's correct. It would work. 10 tens, it would work. But the faster way, or the more efficient way to do this, would be to put up the 100 squared. So 110 times 110 will give me 100. And now we say 110 times 1 will give me 10. 110 times the other 1 will give me another 10. Or we could have just said 10 times 2 will give us 20. So you stick that in and make it tight. Here we are going to say 7 ones. We're just going to speed it up and say 7 ones times 110 will give you 7 times 10 will give you 70. So we're going to put up 7 tens. Come on in. All right.
Yeah, 7.
But we're not finished because we are trying to make a
Rectangle.
rectangle. So now we have to fill in this area right here. So we're going to say 7 ones times 2 ones will give us, what's 7 times 2? 14. And because we're using ones, we use ones here. So we have 14 ones. So we can slide those in. This takes a while.
Y'all need some more words.
Miss Harris.
Thank you.
What?
Thank you.
I forgot they had an extra. We found an extra.
Okay. So now we have constructed our area model, but we still are not finished because we now have to find the product. So how much did we say the yellow square was worth? 100. And how much are these 2 tens worth? 20. And how much are these 7 tens worth? 70. And how much are these ones worth? 14. So now we can add 100 plus 20, and we get 120. We can add 70 plus 14, and get 84. And then we can just add this together and get 204. Or we could have said, okay, I have 100, I have 90 tens, or 9 tens, excuse me, and then we have 14 ones. And we could have done it that way. And that is the area model. I like my traditional way a lot better than having it. All right, now, the next one, here's what you have, or should have, on your dry erase board. This is the open area model. And what I have my children do is they just off to the side, they will draw a box. So if you would just go ahead and draw a box on yours. And we take our decomposed 12 and we will put 10 plus 2. And then we'll take our decomposed 17 and we'll put 10 plus 7. And wherever we have a plus sign, we tell our children, wherever you have a plus sign, that's where you draw your line. Draw a line. Draw a line. And then we say 10 times 10 is 100, which is represented over here. 10 times 2 is 20. is represented right here. 7 times 10 is 70. These are represented here. And then 7 times 2, 7 times 2 is 14, and it's represented right here. And we would go back around the room and we would say things like, show me on your area model where 14 ones are represented. And so the children would have to come back over to their area model and they would say, here are the 14 ones. Where on your area model is the 100 represented? And they would come here. Where on your area model is 20 or 2 10s represented? And go here. Where on your area model is 7 10s represented? And it would be right here. And for my children, they had homework tonight, and they were doing this method for homework tonight. Just drawing a box, decomposing numbers, and multiplying. So, that is that. And that's the same thing. This is concrete, and this is representational. Right. And back to Ms. Clark.
Okay. So when I say earlier, flashing back, or really understanding what multiplication is, that's what this is. You know, back when we were in school, you were given one example, the teacher did one, and then off we went, we did about 40 problems. You had no other choice but to learn it or either get them all wrong. But this shows the kids why it's multiplication. Why that 100, the 12 isn't just, the 1 and the 12 isn't just the 1, it's really worth 10. So we're just trying to let them know what the number represents. And what we're doing is the CRA model. And what it means is we're starting with concrete. What you just did was concrete. Anything that you can put your hands on and build yourself is concrete. And that's what I think all of us did today, is work with those base 10 boxes. They didn't do it today and they did it yesterday. So what you just did was the doing stage, using concrete materials to model problems. Then our goal is to get into the representational stage. This stage is transforming the concrete model to a representational model using pictures or drawings. And why that's important is I always tell my kids, I can't send them home with a bag of base 10 blocks. When they're in Walmart, they can't pull a bag of base 10 blocks out their pocketbook. So our goal is to keep moving forward. We start here, but we don't want to stay here. And to end up at the abstract models, the concept symbolically using only numbers, notation, and mathematical symbols. So by next week when we get to U.S. traditional, which is the method we learned in school, they know, they're doing it the way we did it, but they know what they're doing and why they're doing it. Now look at the bottom portion of your handout, because we just did the top part, that's what Ms. Gainey did. The bottom 3 portions is what we're going to look at next. Why study the partial products method? And that's what we're going to lead to, because that's one of the strategies. To build an understanding of numbers, additional strategies allows for sense making and development of conceptual understanding. Additional strategies supports a range of students' identities and needs. The standard calls for a standard algorithm. Partial product is a standard algorithm. And basically, we want to give our students different strategies and let them use the one that works for them. That's the goal. If they don't understand U.S. traditional or they can't remember those steps, maybe partial product will work for them. Or maybe partial product might not work for a child and they have U.S. traditional. When you're only given one way, either you succeed or either you fail. But when you have 2 different ways, you can choose what works for you. It is crucial for students to know and understand place value. We hit this at the beginning. The black is what they already know. They know anything times 1 is going to be itself. Then they quickly learn, when they're learning those multiplication facts, 10 times 10 is 100. And again, we're going to try to get them into tens and hundreds. 10s times hundreds is thousands, and 10s times thousands is 10,000. Ms. Hicks?
Okay, now if you look at the bottom of your sheet also, you're going to see something like at the bottom partial products method, and that's what I'm gonna share with you right now. This is what Ms. Gainey actually did. This is a different example. This is 52 times 46. And she showed you this representational method. If you look at this, it's sort of like the way you used to write it yourself. I'm multiplying 6 ones times 2 ones, and that's in the green. And my answer is going to go here, and that's in the green. And going back to this one, I would put my 12 here. The 6 ones times 5 tens, because this is actually in the tens place. If the purple represents this is going to be 300, and it's going to be represented here. The next step is to move over to this place value, which is tens, and multiply 4 tens times 2 ones, yellow, which would be 80. The answer would go here. And then the 4 tens times the 5 tens, which would be 2,000, and that would go there. And this is an example of the finished product. They're stacked up and then they're added up. And that's looking a little bit different than the U.S. traditional algorithm that we were talking about. All right. So here we go. This is the one we're working with on our paper. And on one side of your paper, it gives you an example already done. And this is the example. I've got the 12 times 17 that we just did the area model and open area model for, and the partial product. The 12 times 17, again, 7 ones times 2 ones equal 14 ones. The answer goes right here. The 7 ones times the 110 gives me the 7 tenths, which is 70. The answer goes right here. And notice how I'm stacking them up on top of each other. It's real important that they get their digits stacked so that they don't cross over. Sometimes I find that they make mistakes just by not lining them up correctly. Then I've got the 110 times the 2 ones, which gives me 20. And the 110 times the 110, which gives me 100. I'm going to add them up. And again, here is the open area model for the same thing, which, if I can pull it up, you can see better. All right, and here we go with the U.S. traditional deal.
Basically, U.S. traditional, like I've been saying the whole time, is how we learned it in school. But now that you can see the place value and the partial product, you know why it works. Okay. Get wherever you need to. When we were in school and we were given 12 times 17, we immediately went into action. 7 times 2 is 14, carry 1. 7 times 1 plus 1 is 8. What was really going on that teachers didn't stop to tell us was what Ms. Harris just said. 7 ones times 2 ones is 14 ones. But we can't put 2 digits in the one place. We could put 4 and carry that extra 10 to the tens place. Then we go again. 7 ones times 110 is 7 tens. Then we add on that extra 10 that we got over here. That makes 8 tens. So that's why it's 84. And we go over to this one, and I don't know about y'all, but I was just told, put a 0, and you keep rocking and rolling. I didn't know I was putting a 0, they just said put 1. Later I found out that that 1 isn't really 1. That 1 is really 10, or 110. So when I'm doing 10 times 2 we all know is 20. So that's why I needed that 0. Didn't know it then. 10 times 10 is 100. And all I have to do is add those together. So I'm adding 4 ones and no ones gives me 4 ones. 8 tens plus 2 more tens, 8 tens plus 2 more tens makes 10 tens, and we all know that's 100. So I put my 0 here and take my hundreds to where it belongs, the hundreds place. I had already created 100, and the additional 100 I just added on makes 204. So you have created 12 times 17 with your hands. You've drawn the picture of 12 times 17. We saw the partial product with Ms. Harris, and this ties it back to how we learned it earlier. And that's our goal, to get our children to be able to do that U.S. traditional. So they will receive a paper like you have, And we would expect them to be able to do the US traditional, put that in words, because if they can explain it in words, they really understand what's going on. And tie with this, partial product, words, and then US traditional. And again, that's just giving them more options. You don't have any questions? We threw a lot at you, and on a regular school day, we would never go this fast. We but we only have an hour, so I don't think y'all want to stay too much longer than that. Does anybody have any questions? Any questions, concerns? All right, and if you're looking for something, this was created, or our math coach pulled this together if you want to practice multiplication at home. You need playing cards, and basically, did we get the instruction print off? If not, we can. She didn't print that slide off, did she? I think she was gonna print the slide, was gonna run copies. But we could send them home, we could write a note and say I would like a copy of their directions. But basically you need number cards 2 through 9, aces and kings. You can use, aces will be a 1, king will be a 0, and you get rid of everything else. 2 players, and your whole goal is to get the largest product. You want your kids to be able to think strategically. Where should I, when I flip these cards, where should I put, what place should I put this number to get the greatest product? So if you flip a 1, you don't want to put that in your greatest, place value. You would want to put a big number there and make it work more, but you want them to get that. The directions. Shuffle the cards, place the deck, number side down on the playing surface. Each player draws 4 cards and forms 2 two-digit numbers. There are many possible ways to form 2-digit numbers using the 4 cards. Each player should form their 2 numbers so that their products are as large as possible. So what that means is if I have, oh, it went behind there, bring it back. If I flip 9, 3, 5, and 5, I would probably do mine that way. I wouldn't want my 9 in the 1's place because then it's just worth 1. I want my 9 in the 10's place because then it's worth 90. So they have to think strategically like that. And player 2 would do the same thing. And the purpose is extra practice. They can use US traditional, partial product, whatever's good for them to get their product. Players can use any of the methods to get their product. Scoring. The player with a larger product wins the round. Players should record their products in the score sheet below. So whatever my product is would go here. Player 2's would go there. Winner is the one with the largest product. After you've done that 3 rounds, just because you lose a round doesn't mean you've actually lost. You add up all your products, and whoever has the greatest of all is the winner. But with kids, you can call it a game, and they're all for it. Call it homework, you can give it up. You know what I'm saying? So that's just something that we always try to, when we present games to parents, we try to keep it reasonable. It doesn't require a lot of pieces, just a deck of cards that you probably already have laying around the house. And that concludes our presentation. Any questions? And again, anything that you heard tonight, because we do know it was a lot of information, send a note with your child. If you say, I need that sheet again. Can you explain how you do that again? Jaheim here is one of mine, and his grandma had a question about one, asked me to work it out. I worked it out and sent it back. So we're willing to do whatever to make your life easier, because this is new math, so to speak. So if y'all don't have any questions or anything, you consider yourself dismissed. And I think we have some tickets. We have some tickets for your kids. And again, thank you so much for coming.